Hello class, this is the first video of class 9 mathematics. So this is your class 9th based on NCERT. So we'll talk about number system. So what is a number system? It is basically a collection of all the different classification of the different types of numbers, and those numbers when combined together they form a system that is called a number system. So a number system, which is basically one we are what we have is the numbers. Now these numbers are classified into real number and non-real number. Now this real number can further be classified into rational number and irrational number. Irrational number. Right now, what we are doing the classification only. After this, we will discuss about each and every type, different classification, the different types of numbers, the real number, rational number, irrational number. So now this rational number, it can further be classified into integers and non-integers. Now these integers, they can further be classified into positive integer, zero, and negative integer. Okay. Now this positive integer is also called as natural number, and this natural number when combined with 0 is called your whole number. And this non-integers, if we talk about non-integers, then this non-integer can further be classified into terminating numbers and non-terminating but recurring numbers. We'll also discuss about terminating, what is terminating and what is non-terminating, also what is recurring. The terms that I written now, recurring is important. Why? Because when you talk about irrational numbers now, in these numbers are non-terminating and non-recurring. Okay, now we'll discuss about each and every component here. The first component that we know of is natural number, which start from 1, 2, 3, 4, dot, 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 dot. These are called your natural numbers. It starts from 1. These are also called your positive integers. Okay. Now, when I add 0 to this, 0, 1, 2, 3, 4, it becomes a whole number. So whole number basically starts from 0 and goes to dot 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 So now this 0, what is this 0? Is it a positive integer, negative integer? 0 is neither a positive integer nor negative integer. So, but it is an integer. It is a part of integer. So, what is basically 0? Suppose this is your number line. Okay, this is your number line. Now, what happens now? This is a 0. So, 0 is the point of reference. Whenever we measure anything, now we need a point of reference from which we calculate or measure things. Now, the numbers that are lie on the right side of 0 are called your positive integers, and the number that lie on the left side of your 0 are called negative integers. For example, if I talk here plus 1, plus 2, plus 3, plus 4. These are your positive integers and these are your negative integers, minus 2, minus 3 and minus 4. So integers, what does this include? If I talk about integers, it takes your positive value, 0 and negative values. Also, integers are those numbers that can be written as a whole. What I mean to say now, for example, if I have to write here, these numbers are complete in itself. Okay, I need not write 4 as 4 is to 4 is to 1 or 4 is to 2. So this is not written in the form of fraction. So these are your integers. And what are non-integers? Now we'll talk about non-integers. Non-integers. These numbers are written in the form of a fraction. Let's say a upon b, where a and b are integers and b is not equal to 0. So what does this mean? If I talk about 7 upon 4, or let's say 5 upon 8 or 4 upon 5. So these numbers are fractional values. This 7 upon 4 can be written as 1, 3 upon 4. So this is basically 5 upon 8 only, and this is 4 upon 5. So these numbers are not whole. They cannot be written as a whole. So these fractional values are called your non-integers. Now, let's talk about recurring and non-recurring. That will help us understand what is rational numbers and what are irrational numbers. Okay. Now, when I talk about a number, for example, if I take an example of a non-integer, let's say 4 upon 7. So what will the value of 4 upon 7? It's equals to 0.5714 8.40 again 571428. If you'll further divide this number now, it will come in a pattern 571428 dot dot dot. So what this means now, you see this from 5 to 8, 571428, this number will get repeated, 571428, 571428. So there is a pattern of the number that reoccurs after an interval. What is the interval here? 1, 2, 3, 4, 5, 6. So after 6 digits, this number gets repeated itself. So therefore, these numbers are called non-terminating but recurring, because these numbers reoccur after an interval. So these numbers can also be written as 0.571428 bar. This bar represents that these digits are repeating or recurring themselves. If I talk about a number, for example, if I take 4 upon 3, so this is basically 1.333333. It will go on and on. So this 3 is again repeating. So this is also non-terminating but recurring. Okay, this can further be written as 1.3 bar. Now, if I talk about a number, for example, if I take 5 upon 8, so this is basically 0.625. So when I calculate now 5 upon 8 fraction into decimal, what happens now? That this number gets terminated after an interval. For example, here 0.625, there cannot be further, this cannot be further uh, extended. It cannot be extended further. So this gets terminated. So these numbers are called your terminating numbers. Now, when you talk about a rational number now, when you talk about a rational number, these numbers can be written in the form of P upon Q, where P and Q are integers and Q is not equal to 0. Okay, so I got three conditions here. The first is, let that be any number. Let's say this A. This should be written in the form of P upon Q. Should be written in the form of P upon Q. Okay. Also, P and Q are integers and Q is not equal to 0. So when I talk about 5 upon 8, okay, this number is written in the form of P upon Q. This is my P, this is my Q. Okay, first condition is match, where P and Q are integers. So 5 and 8 both are integers. 5 is an integer and 8 is also an integer. So second condition is also match. Third condition is Q is not equal to 0. Here Q is equal to 8, which is not equal to 0. So third condition is match. So we can say that 5 upon 8 is a rational number. Now, what about if I give you some more examples? What about minus 3 upon 4? What about minus 3? What about 4? What about 0? What about root 5? And what about root 5 upon 2? Now, when you look at these examples, here, please look at the first one. Look at the first one. This is written in the form of P upon Q. Now, this is written in the form of P upon Q. wherein P and Q both are integers. Minus 3 is an integer. This is also an integer. So two conditions are met where Q is not equal to 0. So all conditions are met. So this is a rational number. Okay. Now when you talk about minus 3, when I talk about minus 3, then this minus 3 can also be written in the form of minus 3 upon 1. Here minus 3 and 1 both are integers. Also this is my P. This is written in the form of P upon Q now. So here Q is not equal to 0. So all the conditions are matching. Therefore, I can say that this number is also my rational number. Similarly, you tell me about 4 and let's talk about 0. This 0 can also be written in the form of 0 upon 1, which is basically 0. Okay, here Q is my 1, P is my 0. So 0 is an integer. We already have discussed here. See, integer 0 is an integer. So 0 is an integer and 1 is not equal to 1. This is 1 is my Q now. So 1 is also my integer. So first condition and second condition is matched and Q is not equal to 0. So this here third condition is also matched. So we can say that my 0 is also my rational number. What about root 5? Yeah, okay. Root 5, if I talk about root 5 can be also written as root 5 upon 1. So first condition matches that this number can be written in the form of P upon Q. So first condition matched. What is the second condition? P and Q both should be an integer. Whatever when you talk about root 5 now, root 5 is not an integer. What was the integer? Integer was those numbers that can be written as a whole. For example, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or minus 1, minus 2, minus 3, minus 4, minus 5. Here, root 5 is not an integer. So the second condition of P and Q being integer is not matched. So therefore, root 5 is not rational. Then what it is? It is your irrational number. We will talk about irrational number also. Similarly, this root 5 upon 2 is also irrational. Now we'll talk about irrational number. What are irrational numbers? So when I talk about irrational numbers, what are irrational numbers? These numbers cannot be written in the form of P upon Q where, just let me DND this, okay, where P and Q are integers and Q is not equal to 0. The conditions are very important. The first condition is it should be in P upon Q form where P and Q are integers, Q is not equal to 0. So what are irrational numbers? These numbers cannot be written in the form of P upon Q where P and Q are integers and Q is not equal to 0. So when I talk about root 5 now, so root 5 can be written in the form of P upon Q, but P and Q both are not integers. Okay, when these numbers are represented now, then these numbers are called your irrational number. There are some other examples of irrational number. For example, I take root 2, root 3. Tell me root 4 an irrational number? And then root 5, root 6, root 7. You can take these root 11. So when you talk about root 4, so root 4 is basically my root under 2 into 2, which is 2. So 2 is my rational number. Therefore, my root 4 is my rational number. Okay. Now, when we talk about rational, we understood the rational irrational term. Now, what is my what? How do I know a number is rational or irrational when it is given the fractional value or at a decimal value? If I say a number, for example, if I say a number 0.01001001001001, you can see this dot dot dot. This is also non-terminating, but you see there is a pattern. Okay, there is a pattern of these numbers. These numbers are repeating themselves, so therefore they are recurring, but recurring. So these are your rational numbers. What if I take another example? If I take 0.0100100010001 00001. So these numbers are not repeating. Here is 01, here is 001, then 0001, then 401. So these numbers are not repeating. Don't go into finding the sequence. We don't need a sequence here that it is increasing by 10. No, we don't need that. We only require to know that numbers, the digits are repeating in there. So if these numbers are not repeating now, so these are also your non-terminating dot dot dot, non-terminating and non-recurring. When you find a number that does not terminate and that is not recurring, then these numbers are called your non uh, irrational numbers. Irrational numbers. Now, how do I represent an irrational number or rational number on the number line? Suppose I'll just give you a brief uh, introduction of how to represent. We will do the deep analysis of representation with the help of construction in the next class. Today we'll just discuss about the numbers only. 3 plus 3 minus 1 minus 2, this is minus, and this is minus 3. When I talk about root 5, if I talk about root 5, where do I represent root 5? I don't know the value of, if I suppose I don't know the value of root 5, then how do I represent it? First thing that I do is observe this number. This is root 5 now. So this basically lies between the 2 square and 3 square. If I talk about 5, okay, if I talk about 5, then this will lie between 2 square and 3 square. If I talk about root 5, it will lie between root under 2 square and root under 3 square. Now, which is basically my 4, root 4 and root 9. Okay, now this root 5 is closer to 4. Therefore, we can say that the root 5 will lie near to 2. Now, this is 2.5. So it will lie somewhere here. So this will be your root 5. Again, this is not your exact value. This is just the approximate value by observing just the data. If you tell me to represent root 11, suppose this is your number line. Okay, this is number line 0, 1, 2, 3, 4, 5. If you tell me to represent me root 11, I know this lies between the root of 3 square and 4 root under 4 square. This is basically root 9 and root 16. So since 11 is closer to 9, what I will do now? I will represent 11 towards in this part. Okay, somewhere around here I will represent root 11. But again, this is not exact value. We will find the exact value with the help of construction using the rounder, protector, and the correct measurements. Now, when we talk about these numbers, rational number and irrational number, then we talk about the real numbers. Okay, we'll take another page here to understand this. So let's take an example. This is a real number. So these numbers, the first thing that comes in my mind is these numbers are real. What do you mean by real? Real means these numbers have an arithmetic value. Okay, should have an value, arithmetic value that can be used to determine or to measure some units like distance or temperature or anything. So these numbers have some values in associated with it, the defined value, the definite value, and okay, how this and they can be represented on number line. Represented on number line. So when you talk about real numbers, suppose this is a number line. Okay, this is a number line. This is 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, minus -6. So when you talk about any number, any real numbers, these numbers can be represented on number line. So what are the real number? Rational, irrational, then integers, non-integers, then positive, 0, negative. Okay. Now these negative numbers, if I say for example -3, yes, -3 can be represented here. When we talk about, let's take a different color for this. So when I talk about 0, yes, 0 is here only. So 0 is also represented. Any positive integer, for example, if I take 3 or 4, let's take 4. So 4 can also be represented. Then this non-integer, for example, if I take minus 3 upon 2. So minus 3 upon 2 is basically minus half, 1 and a half. So this is 1, this is half. So this is your minus 3 upon 2. If I have to represent 4 upon 7 upon 4, 7 upon 4 is basically 1.75. So it is somewhere here. It is your 7 upon 4. Now when you talk about so all the rational numbers are represented. When you talk about irrational number, we have already represented root 5 now. Where it was? It was somewhere here. Here is the root 5. Here is your root 11. So these numbers are also represented. But when you talk about non-real numbers, when you talk about non-real numbers, real numbers, these are also called complex numbers and they cannot be represented on number line. So when I take about non-real numbers, what are non-real numbers? What if I take for example, if I say you to find me the value of root 4, you will simply say 2. Okay. But if I tell you to find me minus root 4, you will tell me minus 2. Okay, understandable. But if I tell you to determine the value of root under minus 4, how will you determine? For this, we have to understand how these values come. So when I talk about this root 4 now, root 4. When I factorize this root 4, then it will be 2 into 2. That is your 2. When I talk about minus root 4, it is your minus 2 into 2. That is minus 2. When I talk about root under minus 4, this is your root under minus 2 into minus 2. Now this minus and minus will become your plus. If I take this, this is the root 4, but this is not equal to this, which means the value of minus root 4 is not this. Okay, means we cannot say root 4 is minus root under minus 4 is equal to minus root under minus 2 into minus 2, that is root 4. This is root 4. So whenever you factorize any numbers now into like, if you have to find value of minus root under minus a square, this is basically your root minus a into minus a. Now when I multiply this minus and minus, it will become plus. So this is not possible in case of root under minus a square. We cannot find the value of root under minus a square. But if I say you, what about the value of a cube and cube root of a cube minus a cube? If I tell you this, so this you can find how root under minus a into minus a. Basically, the answer will be minus a. But in case of square, now since it multiplies itself, okay, so it becomes your even number. But this is not possible. This cannot be calculated or determined. Therefore, these numbers are also not represented on number line. If I draw a number line here, okay, this is 0, this is 1, this is 2, this is 3, minus 1, minus 2, minus 3. If I tell you to draw me root 4, root 4 is basically here. So this is your root 4. If I tell you to draw minus root 4, so this is your minus root 4. But if I tell you to draw me root under minus 4, this cannot be represented here. Okay, because root under minus 4 is not equal to minus 2. Okay, minus 2, the square of minus 2 will be 4. Okay, minus into minus is 4 plus. Okay, so we cannot find the value of minus root under minus 4. So there are some other examples of non-real numbers. For if I take some other examples are minus root under minus 2, root under minus 3, root under minus 4. These numbers cannot be determined. Therefore, these are called your non-real numbers. Now we'll try to understand all these things with the help of a diagram. So let's take some examples. If I tell you to let's take 1, 2, 3, 4, dot, dot, dot. So these numbers are your natural numbers. So these numbers are your natural numbers. Natural number. When I add 0 to this natural number now, when I add 0 to this natural number, then it will form your whole number. Okay, these natural numbers are also positive integers. Let me write it clearly. Positive integers. And when I talk about some other examples, these are your positive integers and this is 0. And when I talk about negative integers, for example, if I take minus 1, minus 2, minus 3, minus 6 or any other number that is negative, so these numbers are your mm, so these numbers are your negative integers. When this positive and negative integers along with zero combines, they form your integers. Okay, one thing that I made a mistake is when I talked about these only now, when I talk about this is your negative integer. Okay, this is your negative integer. Negative integers. And this negative integers along with your positive integers along with zero when combined together they'll form your integers. Now these integers and these integers when combined with non-integers, what are non-integers? For example, if I take 4 upon 7, 3 upon 2, or 5 upon 8, or even if you take some other example like 2 upon 3, when you combine them now, let's see if it can, okay, when you combine them now, before combining, let's classify them first. So these are your non-integers, non-integers, and these integers along with your non-integers when combined together, then they will form your real rational numbers. Rational numbers. Now, rational number comprises of integers and non-integers. Integers comprises of your natural number, or a zero, and for your negative integer. So now, when you talk about irrational number, for example, if I take here, let's take root 2, root 3, root 5, root 7. What are these? These are your irrational numbers. So these are your irrational numbers. Rational numbers. Now, when these rational and irrational numbers are combined together, when rational and irrational numbers are combined together, they form real numbers. They will form your real numbers. Now, when this real number and non-real number, we have already have discussed that your non-real number, like for example, if I say root under minus 4, or root under minus 3, root under minus 5. So when these numbers, these are what? These are basically, let's see if it can form. Okay, okay, yes, this is nice. So when I talk about these numbers, I know. When I talk about these numbers, these are your non-real numbers. Non-real numbers. So when I talk about combination of real numbers and non-real numbers, what will they form? They will form your number. Now, this whole thing is your number system. Number system. Okay. So this is a number system. Now, I think you are understanding all the things. See, This is a number system. Uh, this is a number system. Okay. Ink is removed when you scribble over it to bring it back. Select undo. Okay. Now see, this is your number system, and this comprises of your real numbers and non-real numbers. This real numbers, this is your real number. Let's take a different to point it out. It comprises of real number and non-real numbers. Okay. Now when these two are combined, they form number system.
When your when we classify real number, we classify it into rational and
Irrational number, and this is your rational number. Now when we classify rational number again, we classified into integers and non-integers. This is a non-integer, and this is your integers. Now integer again classifies into positive. This is a negative one. This is your zero, and this is your positive. So they all form your integers, and integers along with non-integers, they form your rational number. Rational number along with your irrational number will form your real numbers. Real numbers along with your non-real numbers will form your numbers. Okay. So this is the number chart. This is the chart diagram of the number system. Now, if you have understood the class, let's go through some questions. Okay, the first question is, are all natural numbers whole number? You have to tell me why. Second question is, are all non-integers rational number? Again, you have to tell me why. Third question is, are all rational number a real number? Why? If yes, you have to give me the reason. If no, you have to give me the reason. The fourth question is, are all rational numbers a whole number? Again, why? In the next class, what we'll do now, we'll do some how for the next topic. What we'll do, how to represent a decimal value. For example, if I say 0.47 in p by q form, where q is not equal to 0 and p and q both are integers. And what we'll do now, we'll also try to understand to represent irrational number on number line with the help of construction. With the help of construction. Okay, so these things that we will do in the next class. We'll also learn some basics of long division method. It would I will do one question of long division. Long division, although it has been removed from the syllabus, but I think this is an important topic to discuss. So we'll do this. Okay. Now take care, everyone. Till then, have a good bye. I wanted to make him sit. Mm, he has a book here, and let's make him write. Okay, so bye bye. I'm very bad at drawing.